In this lesson, we will learn the easy way to find formal charges, which is written as Fc throughout the video. The formula involves taking the number of an atom's valence electrons, minus sticks, and minus dots. Sticks is the number of bonds to other atoms, and dots is the number of unbonded electrons. You can skip the rest of the video if the formula makes sense and you wish to begin problems, or you can continue to view 3 example problems in this video. First, avoid the common mistake of trying to assign formal charges to a molecule. Remember that formal charges only apply to single atoms, not molecules. Molecules only have overall charges. To provide an example, here are the formal charges of each atom in carbonate. The overall charge is -2, since it's the sum of all the individual formal charges of 0, 0, -1, and -1. As a pre-step for finding formal charges, you have to draw in all the hydrogens and lone pairs on an atom to show their octet. If you overlook any groups, there's a higher risk of finding the wrong answer. So it's very important to do this step before we continue. For the first molecule, we're going to find the formal charge of the atoms highlighted in pink, which is the nitrogen and the carbon on the benzene ring. For nitrogens, oxygens, or halogens, since they are called heteroatoms, we only need to fill in lone pairs to show the octet. For any carbons, we fill in hydrogen bonds to complete the octet. As you can see, nitrogen already has 4 bonds and does not need any lone pairs. Just to clarify, the double bond on the nitrogen counts as 2 individual bonds. For the pink carbon, we only have 3 bonds, which means that there are only 6 electrons in its orbital. Therefore, we need to draw in 1 hydrogen bond to show the octet and complete the 8 electrons. Now, let's calculate the formal charge of the pink nitrogen. It has 5 valence electrons, minus 4 sticks, minus 0 dots. I'm circling the 4 sticks on the nitrogen with the brown dotted lines, and the double bond counts as 2 lines or 2 sticks. So 5 minus 4 minus 0, that would make it +1, and we would draw in the charge. For carbon, it is 4 valence electrons minus 4 sticks minus 0 dots, which gives a formal charge of 0, and by default, we don't need to write that in. For example 2, I've highlighted in pink 2 oxygens and 1 of the carbons on the ring. Now remember, heteroatoms such as nitrogen, oxygen, or halogen need lone pairs to show the octet, and carbons need hydrogens to show their octet. So for the top oxygen, it has 2 bonds, therefore it needs 2 lone pairs to show the octet. For the oxygen on the right, it has only 1 bond, therefore it needs 3 lone pairs to show its octet. And lastly, for the carbon, we draw in 2 hydrogen bonds since only 2 bonds to carbon are shown. For the formal charge of the top oxygen, we have 6 valence electrons of the oxygen minus 2 sticks minus 4 dots, which gives us 0. For the oxygen to the bottom right, again we have 6 valence electrons minus 1 bond or 1 stick minus 6 dots, and that gives us -1, and so we draw in the charge. Lastly, for the carbon on the ring, we have valence electrons of 4 minus 4 bonds minus 0 lone pairs, and that gives us a formal charge of 0, which we do not have to draw in. Example 3 is interesting since we have a carbon with a lone pair. It's currently showing 2 bonds to other carbons and 1 lone pair. Since we need to fill in hydrogen bonds for carbons, we just need 1 more hydrogen to show its octet. Therefore, the formal charge would be Fc equals to 4 valence electrons minus 3 bonds minus 2 dots for the lone pair, and that would equals to -1. Once again, the rules for finding formal charge is valence electrons minus sticks minus dots and applied to atoms only. Don't forget, before calculating, to take a moment and show the atom's complete octet either through lone pairs or hydrogens so you minimize on mistakes.